All right, so I've got cut off right in the middle of that last example. So we'd found the factors of 12 that gave us a difference of 1, 3, and 4. So we put down an x with a 3 and an x with a 4, and then we were looking to the middle sign to tell us the larger factor sign. The larger factor sign is positive. And when we have a difference, a negative here in the constant term, then the other sign is the opposite. So our middle sign was a plus, and then the opposite is a minus. And there we go. That's how that one factors. So now let's go ahead and look at our next examples here. And maybe you pause them and you try them on your own before you see me do these. So if I start out with my factors of 6, 1 and 6, and 2 and 5, or 2 and 3, and remember I'm looking at this to tell me if it's a sum or difference. When it's a positive sign, it's a sum. So I'm looking at the factors of 6, 1 and 6, or 2 and 3 that sum to 5. And so my sum of 5 is given from 2 and 3. So I'm going to put an x with a 3 and an x with a 2, and it's probably worth saying that it doesn't matter which one comes first, right? That's the commutative property of multiplication. And then I'm going to look to the middle sign to tell me what both of these are, because they're going to be the same sign when we're adding. So there we go with minuses, and that's my final answer on that one as well. Right, now again, we're looking at the factors of 12, so 1 and 12, and 2 and 6, and 3 and 4. And again, I'm looking at the sign of the constant, so here we go, sign. This is telling us that it's a difference, since how it's a subtraction. So this is a difference, and I need a difference of the middle term here, which is 1. So 3 and 4 are going to give me a difference of 1. So I need an x with a 3 and an x with a 4. And it doesn't matter, I could have written x with a 4 and then x with a 3, doesn't matter. This sign goes to the bigger factor. So that's a negative, and then the other factor is the opposite, which is a positive. And there we go. There's my factorization. And remember that you can always check these by multiplying out. Remember that a check for these says distribute, 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 distribute. So x times x, which gives us x squared, minus 4 times x, which is 4x, plus 3 times x, which is 3x, minus 12, and then combining the like terms here, x squared minus x minus 12, and we see it's a check. So that is the way we check those. Now there's another way to check it as well, and your book talks about this as using your calculator. Remember that we can substitute in values and check these, but you have to have a whole bunch of values to ascertain that every single one of them are being the same. So you could say, let's evaluate this at x equals 0 and see if the value at x equals 0 is exactly the same for the original. And then the same thing with x equals 1, and the same thing with x equals 2, and seeing that they're exactly the same in each and every time. And that's what your book's referring to as using your calculator to get a table of values. Next problem, we have a y. And because we have a y down here, that y has to be here in the middle term, just like when we have an x squared here, there's always an x in the middle term. Well, when there's a y squared in where we'd expect to see just a constant, we have to see a y here, and if we do, then what we're going to do is we're going to write the x here, but we're also going to just put a y in here, and an x here, and a y in here. And then I'm going to ignore it from that point on out, and I'm just going to get the factors of 2, and this is a minus, so that's telling me that this is a difference, the factors of 2 that give me a difference of 1. So that would be 2 and a 1, and then I need the bigger one to be positive, so plus here, and then the opposite there, and that's how that one will factor. Alright, so now we're going to move on to some more down here. Maybe you want to try these 3 problems on your own before you come back to the next video and see if you are getting these correct.